This is a question from an AS1 exam. This is on turning points and also on increasing functions. So the question says, the function f of x equals 2x cubed minus 3x squared minus px plus 6 has a turning point at x equals 2. Find the value of p. Now there's a few words which are sort of buzzwords. So if you see the word gradient, tangent, normal, maximum, minimum, turning point, any of these things, you really want to be thinking of dy by dx. So we don't have this in terms of y at the minute. We've got f of x, which is equivalent to y. So if you differentiate y with respect to x, you get dy by dx. Differentiate f with respect to x, you get f dash. And if you differentiate dy by dx with respect to x, you get d2y by dx squared. If you differentiate f dash, you get f double dash. So these two things are equivalent, these are equivalent, and these are equivalent. So it's just a slightly different way of writing it. So it mentions turning effect, so that means we're going to have to differentiate, turning point, sorry, so that means we're going to have to differentiate. So let's just write down what we've got. We've got f of x is equal to 2x cubed minus 3x squared minus px plus 6. And at a turning point, your dy by dx is equal to 0. So we're going to find f dash of x. So by differentiating the thing above, so that's just going to be to differentiate, remember, multiply by your power and then reduce your power by 1. So that's just going to be 6x squared minus 6x minus p. Okay, so I would just say when x equals 2, your f dash of x equals 0. You could also have said that f dash of 2 is equal to 0, but not very many people like that, to be honest. So I'm just going to leave it this way. It's not actually as nice a way to write it, but it makes more sense. So that means 0 is equal to what you get when you put 0 is what you get, sorry, when you put 2 into the x values. So 6 times 2 squared minus 6 times 2 minus p. Fire that p across to the other side. It will become positive. And 6 times 2 squared is 6 times 4, which is 24, minus 6 times 2, which is 12, which means p is equal to 24 minus 12. So p is equal to 12. Okay, we found our value of p. Right, what I'm going to do before I do anything else is I'm just going to write down my f of x. This is really to help me with the next question. My f of x with my new found value of p, which was 12. So that's what we've got. The next part of the question says, find the range of values for which f of x is increasing. So if it's increasing, if it has a positive gradient, and what your dy by dx is, another word for it is a gradient function. So really, we want to find f dash of x, and what we're going to do is put f of x greater than 0. So if it's greater than 0, that means it has a positive gradient. That means it's an increasing function. So that's what we're going to do. So let's just differentiate that again. Find our f dash of x again. That was 6x squared minus 6x minus 12 then. And we're going to just put f dash of x greater than 0. I.e. that means we're going to put 6x squared minus 6x minus 12 is greater than 0. Now let's make life a little bit easier by dividing through by 6. And then you're going to get x squared minus x minus 2 is greater than 0. And this thing would factorize, so I'm just going to skip that bit out, but it would factorize. You can use your sum of the product or whatever you want. X minus 2 upon x minus 2 upon x plus 1 is greater than 0. Okay, it's a positive. This thing here is a positive U-shape, positive quadratic, so it's a U-shape, and it crosses in when x equals minus 2 or when x equals minus 1. So just put that in, and we want it to be greater than 0, which means we want it to be above the axis. So it's above the axis out here or out this way, which means x is less than minus 2 or x is greater than 1. And hopefully that is the right answer.